A percentile is a statistical measurement that gives the values below which a certain percentage of observations lie. For example, if you're in the 80th percentile of grades in this class, then 80% of students have grades below your grade. Thus, one way of thinking about this is that you're ranked in the 80th percentile of this class. Let's look at the following set of 40 fictitious grades for this class. The first thing we need to do is reorder the data from lowest to highest. To make sure you have all the data, highlight or strike through the numbers once you have put them in order. These are in order. Let's say we want to find the percentile rank for a student who has a 90% in this class. The formula is the percentile for a value of x is equal to the number of scores below x divided by the total times 100. We count all the scores below 90. Notice there are 25 scores. We divide it by the total number of scores, which is 40, and we multiply that by 100. That gives us a 62.5. Remember, the general rule is to round the resulting value to the nearest whole number, or we're in the 63rd percentile in the class. That means that 63% of the students in the class have scores less than 90. This time we're going to use the same set of data, but this time we're going to go backwards. So we want to find the 80th percentile. So K is 80. We divide that by 100, so K is 80. The total number of scores is 40. We multiply this and we get 3,200. We divide that by 100, and that gives us 32. So we want 32 as the position locator, so we go over 10, 20, 32. The 32nd score is 95. So the 80th percentile is the score 95. The formula is the locator value, or position value, equals k over 100 times n. You will notice that some books use slightly different formulas to calculate the percentile. While most students find this very disturbing, actually with large sets of data, percentile ranks and values at given percentiles produce fairly accurate results. However, with small sets of data, the score at a given percentile can have different values depending upon the methodology. Now let's consider how to find quartiles. Our goal is to separate the data into quarters. The first quartile is Q1. That is the 25th percentile. The second quartile is Q2, is at the second quarter mark of the observations or scores. We'll call the second quartile, or the 50th percentile. The third quartile, labeled Q3, is at the third quarter mark of the observations or scores. We call this the third quartile, or the 75th percentile. And the fourth quartile is Q4, or the 100th percentile. We first put the data in order from lowest to highest. Notice here we have 10 pieces of data. The middle of the data is here. We take the average of those two middle scores to get the median. So the median, or the second quartile, is at 5. 4 plus 6 over 2 is 5. The first half of the scores, there are 5 pieces of data. The middle score here is the first quartile, which is 2. And the middle of the second half of the data, the third quartile, is 8. Another way to find the percentiles or quartiles is to use the normal curve. This is used most frequently in very large data sets. Why? Because if you have 10,000 pieces of data and you wanted to find the percentile at a given value, it's not practical to count all the scores below that value. It is much more reasonable to use the previous methods when you have scores of 100 or less. If you have more than this, it's easiest to find the mean and standard deviation for the data, draw out the normal curve, and compute the z-score, and then find the percentile, or percent of scores below a given score. You would then look up the value using the z-score table. From the empirical rule, we know that there is 97% of all the data within 3 standard deviations of the mean. That means that if we draw a normal curve with a mean in the center and 3 standard deviations to the right and 3 standard deviations to the left, then we have 97% of the data within that range. Percentiles are the percent of observations or scores below a given score. So when doing percentiles, we can look at a normal curve and then look at the scores and percentiles from left to right. At a z-score of -3, for example, the percentile is 0.13. At a z-score of -2, the percentile is 2.28. At a z-score of -1, the percentile is 15.87. At a z-score of 0, we're at the 50th percentile. Note, remember to round to the nearest whole number. Let's say we have computed the mean and standard deviation of years of experience of students who are entering the nurse practitioner program at a given university. Let's say the mean or average number of years of experience in nursing is 12 with a standard deviation of 3. So if we draw a normal curve, we put the mean of 12 years of experience in nursing and then 3 standard deviations to the right and 3 standard deviations to the left. We have 15, 18, 21, and we subtract 9, 6, and 3. Okay, let's say I want to find the number of years of experience you would have to have if you were in the 80th percentile. So the formula is z equals x minus the mean over the standard deviation. If I look up the z-score for the 80th percentile on the chart, I see this is 0.84. That's closest to 80th percentile. And we get x minus the mean, which is 12, over the standard deviation, which is 3. I multiply 3 to both sides. These cancel, and I get 2.52 on the left. I add 12 to both sides, and I get x equals 14.52. So you would have 14.52 years of experience if you were in the 80th percentile of nursing students going into the nurse practitioner program. Percentiles are frequently used in testing and measurement. We have seen in this video how percentiles are used both with a specific set of data and using a normal curve.